missing? I can't see. No, it doesn't matter. All right. Now you can just look at it and try and work out what the transformations are. Okay, that can be done. That's not an issue. Or you can go through the whole steps. So for example 1, I have changed everything and worked out all the steps for you. It says find a sequence of transformations which takes the graph of y equals x cubed to that graph there of 2x plus 1 cubed minus 2. Okay, so what I'm doing is rearranging this one here to make it suit this sort of look. So I'm going the y plus 2 equals the 2x plus 1 cubed. Now remember, this becomes the image because we're going from this graph to that graph. So I'm just putting the x dash and the y dash. So there it is there, rearranged. Okay. Now, equating things. Good, everyone's joined us now. Equating. So as soon as I equate, so I've got, remember, y equals x cubed. That's the original graph. There it is there. And I'm equating it to this. So I get y equals my image, which is y dash plus 2. Yeah, I've got that there, thank you. And my x, which is just inside the bracket. We don't worry about the cubed because they're both cubed. Okay. So just the inside the brackets, 2x dash plus 1. Thank you. And therefore x dash equals the x minus 1 divided by 2. And the y dash equals the y minus 2. So now we can see that. I'm just going to clear this. So we can see if I do it like this, and I'm going to add a little bit in here for those of you, my x comma y has become my x minus 1 divided by 2 and my y minus 2. Be careful with this x minus 1 divided by 2. Really, you should be splitting it up to x divided by 2 minus half, okay, if you can't see it. So we've got a dilation factor of a half, and of course that's from the y-axis because we've got it on the x, definitely from the y-axis. Then we've got a translation, and it's a half in the negative direction along the x-axis, and we've also got a translation of 2 units in the negative direction of the y-axis. Any questions there? If I go back up and look at it, you can probably see that if this equals 0, oops, I forgot to do my, if this equals 0, 2x plus 1 equals 0, x will equal negative a half. So it shows that translation, and I can see the translation there along the y-axis as well. Okay, that's along the x-axis. A bit more difficult to show your dilation. Okay, so be careful if you're trying to do it by inspection. Any questions on that one? Okay, example part B. It says find a sequence of transformations which takes the graph of this time y equals the square root of x to that one there. Okay, again, we're going to just equate them. So I've got my, and these becomes the dashes, my x equals to my 5x dash minus 2. There it is there. And I'll rearrange that and make x dash the subject. So I'll add the 2 and then divide by 5. And my y equals my y dash. And that's already. So I can see my dilation factor of 1/5 from the y-axis. And then we've got 2/5 translation along the positive direction of the x-axis. And there's nothing on the y. Nothing at all. The y dash and equals the y. So that's all my transformations there. Any example, any questions on that one? Okay, clear that one. Example 2. Okay, example 2. In each case below, state the sequence of transformations required to transform the graph of the first equation into the graph of the second. Okay, so here I'm doing it by inspection. Again, if you don't have to do it this way, okay? I've got a dilation factor of 4 here, and that will be from the x-axis. I can see that, okay? You can see it quite clearly, okay? Then I've got a translation 5 units, but remember x plus 5 equals 0, so it's going to be x equals -5. So it's going to be 5 units in the negative direction of the x-axis, and then I have this -3, so this normal graph will be translated 3 units in the negative direction along the y-axis. Any questions there? Okay, part B. Change back to my red. Y equals 1 on x squared, and it's going to go to y equals -3 divided by x plus 4 squared minus 7. So we're going from a truncus to another truncus, but of course there's translations. Okay, the first one, well, you can either write the negative first, which is reflected in the x-axis. Okay, that's up to you. Or you can write the 3 first, which is the dilation factor of 3 from the x-axis. Okay, you can't put them together, it has to be written separate. Then you've got the x plus 4. Of course, that will equal 0 when x equals -4. So you've got a translation of 4 units in the negative direction of the x-axis. And then you have this -7. And again, it doesn't matter if you write to the x or y translation first. You try and keep to the alphabet x first and then the y. So this -7 is going to give us 7 units down, so translation of 7 units in the negative direction of the y-axis. Any questions on part B? Okay, go back to my red. This time we've got a different graph, okay, square root function, similar thing. But look at this, we've got the negative on the inside, next to the x underneath the square root. So that reflects it in the y-axis because the x values and not changing here, belongs to the y values that are changing. Then you've got this 2, okay, so you've got the dilation factor 2 from the x-axis, and then you've still got this +3 here, which is the translation up 3 units in the positive direction of the y-axis. So if you can do it from inspection, and some are easy to do, some aren't, then quickly do it. Any questions there? Okay, I'm going to clear this one unless anyone's writing. Example 3. How many examples have I got? Okay, good. Example 3 says, find a sequence of transformations which takes the graph. Okay, so this time we're going from I call it a bigger graph to something smaller. Okay, so we're going from here to here. Now, a little bit harder. Now remember, we need to invert it. We're working with the opposite. So I'm going to rearrange this graph and get it in this sort of shape. So I'm going to subtract my 6 and divide by the 3 here. And that will become 1 over x minus 1 squared. Okay, so now it's the same thing. My y and equals my 1 on x squared. 1 on x squared, and there's my y. So that's how I got that line there. Okay, so my image is this. So my y dash equals y minus 6 divided by 3. And my image for here is my x minus 1. Okay, now we're not rearranging here. These are the images because we're going from this to that one there. Okay, so now I can see my transformations. I've written it so it's easier for you, just what I've just said. Okay, so what's happening? I've got a translation, 1 unit in the negative direction of the x-axis. Okay, and it's not 6 as a translation in the y-axis. It's -6 divided by 3, because the y minus 6 divided by 3, we're going to split 1/3 of y minus 6 divided by 3, which becomes 1/3 of y minus 2. And really, I should have written my dilation first, which is 1/3 from the x-axis. Factor of 1/3 units from the x-axis. So my dilation should go first. That should go first. And I'm missing the word factor. So make sure you put the word factor in there. That really should go first. And then the other 2 doesn't matter. Okay. But I've got 2 units in the negative direction, translation, along the y-axis. And in my x, I've got 1 unit in the negative direction, translation, along the x-axis. Any questions on that one? I'm going to clear this one so I can write a bit better with the B. Yep.
So going back to example 2b,
Example
part
2b.
B.
Okay,
Example
first of
2.
all, is anyone writing any of this down? Okay, let me clear that. Example 2b, yes.
What would happen if that positive 4 was outside the bracket?
And then if it's outside the bracket, it'll be over here, where the 7 is.
No, but underneath,
It won't be.
in
It
the
won't,
denominator.
never will be. Never will be.
Right.
Never will be. If it belongs with the x, the translation is with the x, then it's going to be inside the bracket. You will not have an x squared plus 4 there. Okay? It has to be in the bracket like that. It won't be like the part A as in x squared plus 5. It will never be like that. It has to be inside it. Okay? Part B, I think it was. Yeah, part B. Come on. Part B says, find a sequence of transformations which takes the graph of this one, again, something bigger to something smaller. So again, rearranging, getting in this sort of thing as an x squared. So we want this part to remain, but we've got to get rid of this plus 6. So I'm going to get y minus 6 equals my 2x minus 1 squared, which is what I've got there. So that is the image. So y dash equals y minus 6, and my x dash equals my 2x minus 1. Okay, so there it is written. And so I can see that I have a dilation of factor 2 from the y-axis. I have a translation of -1, so 1 units in the negative direction along the x-axis, and -6, so 6 units in the negative direction along the y-axis. All right, any questions on that one?